1,000 commits per hour. For an entire week. With zero human intervention. Cursor just showed us what happens when you let hundreds of AI agents loose on a codebase. And they built a working web browser from scratch. This isn't hype. This is a research paper. Let me break down exactly how they did it. On February 5th, Cursor dropped a post that got 640,000 views. Quote, "We've been working on very long-running coding agents. In a recent week-long run, our system peaked at over 1,000 commits per hour across hundreds of agents. Here's the demo they released. So what did 1,000 commits per hour actually produce? A web browser. Written from scratch. The project started as a personal side project. Someone at Cursor asked Claude Opus 4.5 to write a plan for building a browser engine. It failed immediately. The model lost track, claimed success when it wasn't even close, and got stuck on details. But here's the insight: the model could write good code in small pieces. The problem wasn't intelligence. It was coordination. So they asked, what if we threw 10x more compute at it? Could we get 10x more throughput? Their first attempt? Let agents self-coordinate using a shared file. Total failure. Agents held locks too long, forgot to release them, and spent more time waiting than working. 20 agents produced the output of 1 or 2. Second attempt, add structure. A planner creates tasks, an executor assigns them, workers execute, and a judge decides if it's done. Better, but still bottlenecked by the slowest worker. Too rigid. Third attempt, remove the planner. Let the executor plan and assign. This created new problems. The executor would randomly sleep, refuse to spawn tasks, do work itself, and claim it was done when it wasn't. It was overwhelmed with too many responsibilities. After months of iteration, here's what actually scaled. Root planner. Owns the entire project scope. Understands the goal. Delivers specific tasks. Does zero coding. Subplanners. When a task is too big, the planner spawns subplanners that fully own their slice. This is recursive. Planners all the way down. Workers. Pick up individual tasks. Work in isolation. Don't know about each other. Submit a handoff when done. The handoff isn't just "I finished." It includes notes, concerns, deviations, and feedback. This propagates information up the chain. The result? A system that's dynamic, self-correcting, and doesn't require global synchronization. But here's where it gets interesting. To hit 1,000 commits per hour, they had to accept some trade-offs. Trade-off number 1, commit correctness. When they required 100% correctness, everything ground to a halt. One typo would cause every agent to pile on and try to fix it. Instead, they allowed some errors. Agents trust that other agents will fix issues soon. Errors arise, then get fixed. The rate stays small and constant. Trade-off number 2, synchronization overhead. Sometimes multiple agents touch the same file. Instead of over-engineering a solution, they accept turbulence and let the system converge naturally. Spend some extra tokens, get global productivity. It's a trade-off. 3 things you should take away from this research. 1. Prompting is everything at scale. Quote, constraints are more effective than instructions. Saying no to do's, no partial implementations works better than remember to finish. And be specific about quantity. Generate many tasks produces 3. Generate 20 to 100 tasks produces 50. 2. Architecture affects AI throughput. When hundreds of agents compile simultaneously, disk I/O becomes the bottleneck. Project structure, build times, and developer experience directly impact how fast AI can work. 3. The future looks like software teams. Quote, there's a poetic resemblance to how some software teams operate today. These models were not explicitly trained this way, which suggests it's emergent behavior and possibly the correct way of structuring software projects after all. Cursor is making this available as a research preview to some users. If you're on Cursor, you might get access soon. This is the frontier of AI-assisted development. Not copilots. Not autocomplete. Full autonomous agents running for weeks, making thousands of decisions, and converging on working software. The question isn't whether this will change how we build software. It's how fast. If you want more breakdowns like this, subscribe. I'm covering every major AI development as it happens. Drop a comment. Would you trust AI to run for a week on your codebase?